11, I'm going to go through some of the work for today, exercise 312, solving simultaneous equations. Now, when you're solving simultaneous equations, you need to follow some steps. And if you look on our website, I've listed them here. So in today's work, the learning intention is to solve simultaneous equations. You can see that there. And I've put 4 steps down in the success criteria so you can see how you're going with it. Now, the first thing you've got to be able to is decide whether or not elimination or substitution, these are the 2 methods we're going to do, is going to be the best option for you. Making that choice can make the work either hard or very easy. So it's an important choice to make. Once you make the choice, you need to be able to apply the process of the elimination or the substitution method to find one variable. And you'll see that as we go through it. Once you've found one variable, you substitute it back in to one of the original equations to find the second variable, because that's why we're doing simultaneous equations. There are 2 variables in each of these equations. And finally, you can check with both values back in one of the original equations, but you've got to make sure that when you do this last step that you don't use the equation you used to get the second variable. Now, all of this will become apparent when we do some examples, so let's go. So I'm going to do the first one, and the first method I'm going to do is the elimination method, because I've already looked at the first one and I've gone, yes, that suits it best. So the first one here, question number 1, I've got A minus B equals -2, and I've got A plus B equals 4. Now, when choosing the elimination method, all you've got to do is look at the variables and see if they have the same size. So, for example, both my A's in this are 1A. Also, both my B's in this are 1B. One's negative, one's positive. And that'll help us make a decision later on. If I look at question 2, I've got 5x and 2y, and then I've got 3x and 2y. So again, I'm going to choose the elimination method for that because the y's have the same size, the same coefficient. The same with question 3. I've got 4p, 3q, and 5p and 3q. So the q's have the same size, so I'll use the elimination method there. Question 4, well, they're written as y equals and y equals. So there I'm going to use the substitution. And as you go along, you're going to see more examples of where to use substitution. Anyway, so let's get into this elimination method. So I can eliminate either the A's or the B's. Before I do that, I'm going to call that equation number 1. This is important to show an equation, that one equation number 2. This is important to show all your steps because someone needs to be able to come along, read your work and follow what you've done. Now, I could do a subtraction process to get rid of the A's because they're the same size and the same sign. Or I could use an addition process to get rid of the B's because they're different signs. And when I add something of the same size but different signs, they'll go. So I'm going to eliminate the B's because addition is easier in most cases than subtraction. So I'm going to go equation 1 plus equation 2. Now you can see I've written these equations above one another, which makes it very easy to do the addition process because I just add each part. So A plus A, 2A. Minus B plus B, that eliminates. Minus 2 plus 4 is 2. And now you can see I've got an equation with one variable, which I'll now solve. I'll divide both sides by 2, and I'll get A equals 1. Now, I have to substitute that into one of the top 2 equations to find B. Again, choosing the right one makes it easier. So I'm going to sub this into equation number 2 because it's addition and it's going to make it easier. I could have done it into 1. Would have got the same result, but we'll see. 1 plus B equals 4. minus the 1, and I'll get b equals 3. So now I've got my solution. A equals 1, b equals 3. I used equation 2 to get the b. So when I do my check, I'm going to check in equation 1. And if it works there, I know I'll have the right answer. So a minus b equals minus 2. So 1 minus 3 equals 1 minus 3 is minus 2, and that is the right answer. I'm away. Let's have a go at question number 2. And again, we'll use the elimination method. Actually, no, I won't do 2 because I'm going to let you do that. I'm going to do one where they're both the same, but they're the same sign as well. So I'm going to do 5. 2x plus 3y equals 14. 2x plus 3y equals 14. And x plus 3y equals minus 4. X plus 3y equals negative 4. They're both written the same way, so I don't have to do much with them. I'm going to call this equation number 1, and I'm going to call this equation number 2. And this time, the x's are different, so I can't eliminate them, but the y's are the same. I can eliminate them, but they're the same sign. So I can't add them, because if I add them, I'll get 6y, and I want to eliminate the y. So I'm going to subtract them. Now, again, make this easier for yourself. Usually go the bigger one, bigger equation in most aspects, minus the smaller one. So the bigger one to me looks like equation number 1. So I'm going to go equation number 1 minus equation number 2, because in subtraction, order counts. 2x minus x gives me x. 3y minus 3y eliminates. And 14 minus minus 4 is 18. You might want to check that one on your calculator rather than doing that on your own. No. Oh, sorry. I should have checked it on my calculator because I think I've written the equation wrong. Yes. That's minus 14. So my equation was wrong. Now when I do that subtraction, minus 14 minus minus 4 gives me minus 10. I was just looking at the answers very quickly there and I realised my mistake. I would have found out as I got through, but I want to make sure I get these right as we're going along. All right, once I've got x is minus 10, I have to substitute it in. Now I'm looking at these two equations. I think I'll substitute it into equation number 2. That looks easier. So I'm going to sub into equation number 2, and I get negative 10 plus 3y equals negative 4. I add the 10 over, 3y equals 6, and I divide by 3, and y equals 2. So I've got my two values. Because I use 2, I'm going to check in 1. And 2x plus 3y equals minus 14. So does 2 times negative 10 plus 3 times 2, well, it's negative 20 plus 6, which equals negative 14, which is correct. So that's the elimination method. I want to do one more with the elimination method that's going to be a bit harder. So I'm going to do question 12. And it's a bit harder because none of them are the same at the beginning, but you can change them to make them the same. So I've got 3a minus 4b, 3a, and this is question 12. This is question 5. 3a minus 4b equals negative 16. And 2a plus 3b equals 12. 2a plus 3b equals 12. Now I'm going to double check that because I don't want to make the same mistake. 3a minus 4b equals negative 16. And 2a plus 3b equals 12. Okay, so there are my equations. Again, let's call this equation number 1, call this equation number 2. They don't look the same. And if I want to be frank, I'd like to eliminate the b's because they're different signs and it'd be easier to add them. But because they're an equation, as long as I do the same thing to everything, it won't change it. So what I'm going to do is I'm going to make that 4b a 12b. I'm going to multiply everything in that equation by 3. And I'm going to make that 3b a 12b also. So I'm going to multiply everything in this equation by 4. As you can see, I chose those numbers because they're the opposite coefficient in either equation. So you can see the 4 here, so I multiplied equation 2 by 4, and the 3 here, and I'll multiply equation 1 by 3. So I'll write down what I'm doing, even though it looks like I've shown that before. Equation 1 times 3, and I've got to multiply everything by 3, so I'm going to get 9a minus 12b equals negative 48. Now I'm going to go equation 2 by 4. And I'm going to get 8a plus 12b equals 48. Call this now equation number 3, because even though it's the same equation, it's in a different form. And equation number 4. Now my b's are the same, so I'm going to add them. So I want equation number 3 plus equation number 4. And what happens? Well, I get 17a, because 9a plus 8a. The b's eliminate. Oh, minus 48, and 48 equals 0. Well, I'll solve this equation because 0 is a solution, and I get a equals 0. I'm going to sub that back to, I have to go back to one of the original equations. I'm going to sub that into equation number 2. Equation number 2 was 2a plus 3b equals 12. So 2 times 0 plus 3b equals 12. Well, that gives me 3b equals 12. Therefore, I get b equals 4. Now I'm going to check that. Because I used equation number 2, I'm going to check in equation number 1. And equation number 1 is 3a minus 4b. So 3 times 0 minus 4 times 4, that equals negative 16, which is the correct answer. So I'm right. And that's about it for elimination. What are the steps again? See if one of the variables is the same size in both, and if it's not, you can make it the same size by multiplying. Then add or subtract the two equations, get one variable, sub that variable back into the equation of either 1 or 2, find the second variable, and then check it. So I'm going to do 3 more examples, and I'm going to use this time substitution. I'm actually going to do substitution for the first one again, so that you can see it works for both of them. So substitution is when you have one variable by itself as the subject of the equation. So if I look at question 1, and I do this again via substitution, have a minus b equals negative 2. Still got to call that equation number 1. And I have a plus b equals 4. And I still call that equation number 2. And what I'm going to do is I'm going to rewrite equation number 1. And it's very easy. I'm going to add that b over the other side. So I'm going to get a equals b minus 2. I could have written negative 2 plus b. It's just as easy to do that. So I've added the b over the other side. Now I have this equation number 3 and I can do substitution because the A is written as the subject. That's what you want to do. So I'm going to sub 3 into 2, which means everywhere there's a B, I'm going to put that. So I'm going to put that in there. So here I go. A plus B, sorry, I'm going to put it in for the A. So I'm going to get B minus 2 plus B equals 4. Therefore, 2B minus 2 equals 4. I just added the B's. I add the 2 over. 2B equals 6. I divide by the 2. B equals 3. Now, I check that. I sub that into equation 2. And I get A, or I can do it into equation 3. Let's do it into equation 3 because it's written as A equals, so that makes it really easy. So let's not sub it into 2. Let's sub it into 3. And I get A equals 3 minus 2, and that equals 1. Now, because I've already done the check and we know this is already true because we did it earlier, I'm going to let that go. But please remember, if you were doing it as a fresh equation, you would check it. So let's have a look at the ones in the exercise that look like they're going to be easy for substitution. Well, this one straight away, because I can get that x equals. All right, oops, wrong exercise. How did I get down there? Here we go. This one straight away, because they're both y equals. There's not very many that lend themselves to it, because you want to have a pronumeral by itself. Maybe this one, but they've already got 4 x's. This one maybe, because then I can take the y over and I can and bring the 19 back. So they might be the ones. This one maybe. Take the 5n over and you get m equals. Most of the others that have pronumerals in front of them, they're going to be hard. So I'll do question 8. I thought that was going to be a harder one. Question 8. I'll leave you to do question 4. That's pretty easy. I'll do question 9. And you can try 4 and 10 using substitution. So here we go. Here's substitution. And I'm going to do question 9. By the way, you choose what method you want to do. So I've got 5x minus y equals 19. 5x minus y equals 19. And I've got 2x plus 5y equals minus 14. 2x plus 5y equals negative 14. So again, call this equation number 1. Call this equation number 2. Now I'm going to have to rewrite equation number 1. So rewrite 1. And I'm going to take that y over. So 5x equals 19 plus y. I'm going to subtract that 19. 5x minus 19 equals y. And this is going to be my new equation number 3. It's not a new equation, it's just rewritten. And now I'm going to substitute. I'm going to sub that into equation number 2. So everywhere there is a y, I'm going to put that. So I'm going to put it in there. So 2x plus 5. Use parentheses. 5x minus 19 equals negative 14. 2x plus 25x minus 5 90s. Is that 95? Where's my calculator? I had it here a minute ago. 5 times 19, I think it's 95. 5 times 19. Yep, 95. So minus 95 equals negative 14. 30x equals, add the 95. A bit worried about this. Oh, I can't even add. It's not 30x, it's 27x. Add the 95 over, and I get 81. Divide by the 27, and I get x equals 3. I feel a bit better about that now. Once I know what x is, substitution makes it really easy to find the other one, because I just go back to equation number 3. Have a look at it, because it's written as y equals. So, sub this into 3. And please make sure you show all your steps. And I get 5 times 3 minus 19 equals y. 15 minus 19 equals y. Negative 4 equals y. Now I'll check in. Now I've got to be careful here, because where did I get 3 from? I got it from 1. So because I've used 3, I've actually used equation number 1. So I shouldn't use that to do my check. I'm going to check in equation number 2. And that is 2x plus 5y equals negative 14. So 2 times 3 plus 5 times negative 4, well, that equals 6 minus 20 equals negative 14. Hooray. Now, as I said, not a lot of these questions lend themselves to substitution. You're going to do a lot of substitution in the next exercise. Now, this is important. You have to do lots of them. So here's this exercise. I've done 1, 5, 12, 1 again, and 9. So I've done 4 of them for you. You have to do the other 16. Make sure you follow the steps. Decide whether or not you're going to do substitution or elimination. Get one variable by itself. Substitute it back into the equation that you didn't get it, from any of the original equations, and then check. You must check. Anyway, that's today's work. Good luck, and if you have any questions, shoot me an email.